Assistant Professor, Department of CSIT, working at Ahmedabad Institute of Technology. And in previous sessions, we have seen about SGF CPU scheduling algorithm and priority scheduling algorithm. And today in this session, we are going to see about round-robin CPU scheduling algorithm. So what is the overview of this presentation? So only in this, we are having only non-preemptive method for round-robin CPU scheduling algorithm. So what is round-robin CPU scheduling algorithm? It is nothing but each process is cyclically assigned. Each process is cyclically assigned at a fixed time slot. So it is assigned a fixed time slot. So for that algorithm, the process is cyclically arranged and it is under each fixed slot. It is the preemptive version of the first come first serve CPU scheduling algorithm. So it is nothing but it is similar to FCFS and it is nothing but time sharing technique. So round-robin CPU algorithm generally focuses on time sharing technique. The period of time for which process or job is allowed to run in preemptive method. So the time of each process or a job is allowed to run in preemptive method. That is what time quantum. So based on the time quantum that can be arranged according to their preemptive method. Each process or job present in the ready queue is assigned the CPU for that time quantum. So whatever the CPU is arranged for that ready queue, it is having some time quantum. So based on the time quantum, we have to solve that time intervals. If the execution of the process is completed during that time, then the process will end. So after the completion of the process, then only it will end, or else it cannot end. Why? Because the process will be under execution, no other process can enter. So until and unless the end of the process, no other process can enter. Else the process will go back to the waiting table. So it will be under waiting queue or wait for its next turn to complete its execution. So until and unless it completes the execution from the waiting table, no other process can enter. So after getting its turn, then it completes its execution. Until it won't get the turn of that time, then it cannot complete its execution. So what are the characteristics of round-robin CPU scheduling algorithm? It is simple and easy to implement. It is very simple and easy to implement. Starvation free, as well as all process get a fair share of CPU. So until and unless each process gets the CPU, no other process can enter. So it will be arranged in the starvation free of all process and it gets a fair share of the CPU. One of the most commonly used technique in CPU scheduling algorithm is core. So core is nothing but kernel. It is preemptive as processes are assigned the CPU only for a fixed slice of time at most. So it can be fixed only the time slice of that process. No other can execute. The disadvantage of this process, or it is more overhead of context switching. So the disadvantage of this CPU scheduling algorithm of round robin, it is a context switching. So what are the advantages and disadvantages of round robin CPU scheduling? There is fairness since every process gets an equal share of the CPU. So each and every process gets equal share of the CPU. That is one of the disadvantage. Newly created process is added to the end of the ready queue. So whenever the time quantum P1, so the newly arrived will be ended at the ready queue. Ready queue is nothing but first in, first out. A round-robin scheduler generally employs time sharing. It generally employs time sharing, giving a job at a time slot or a quantum. So, giving a time slot or a quantum. While performing a round-robin scheduling, a particular time quantum is allotted to different jobs. So, for different processes, they are having different time quantums. Each process gets a chance to reschedule after a particular quantum of time in the scheduling. So rescheduling means when the processes are scheduled, our newly processes will be under scheduling. So the newly processes will be allotted at last, or that will be according to the time quantum. These are the advantages of round robin. So let us see the disadvantages of round robin CPU scheduling algorithm. there is larger waiting time and response time. So it consists of larger waiting time and response time. And there is low throughput. So there is a low throughput and there is context switchings. So context switches. Gantt chart seems to come to big if quantum time is less for scheduling. For example, millisecond for big scheduling. So it consists some milliseconds as big scheduling, and time consuming scheduling for small quantum. So for every small quantum it consists some time scheduling or time consuming. So this is one of the disadvantage of round robin. So let us see our problem with round robin preemptive method. So consider the following burst time, arrival time of 4 processes P1, P2, P3, P4, and the given time quantum is 2. So based on this time quantum, we need to calculate our round robin scheduling algorithm. So let us start our problem. So in this we are having only 4 processes P1, P2, P3, P4. So what are the arrival times? 0, 1, 2, 4. So 0, 1, 2, 4. So what are the burst times? 5, 4, 2, 1. 5, 4, 2, 1. So time quantum is 2. So what is our round robin scheduling algorithm? It is nothing but it is similar to FCFS and it is a time sharing algorithm. So let us see our Gantt chart. So Gantt chart and ready queue. So Gantt chart. What is our Gantt chart? The process under execution, whereas ready queue is nothing but the processes which are under waiting stage for the CPU. So Gantt chart start arrival time with 0. So now see the arrival time with 0, which process is ready? P1 is ready. So with the burst time is 5. Sorry. So we are having time quantum 2. We need to reduce the value. So 5 minus 2 is remaining is 3 and we need to calculate with 2. So 0 to 2. So now which processes are ready? P1 is ready, P2 is ready, P3 is ready. So as P1 is existing, we need to schedule is next. So next P2, P3 and next P1. So already P1 completed. So next which process is ready? P2. So with the burst time 4. So we need to minus 2 remaining. So now 0 to 4. Which process is coming? P4 is coming for waiting for the CPU. P4. So after P4 next again P1, P2 and P3. So next P2 is completed. Which is ready? P3. So with the process burst time is 2. 4 plus 2 is 6. So P3 completes its execution by the burst time 2 and it's end with completion time of 6. So next which process is waiting for the CPU? P1 with the burst time how much? 3. So we need to do minus, still remaining is 1. So 6 plus 2 is 8. Next which process is waiting? P4. P4 with burst time is 1. So P4 also completes its execution. So 8 plus 1 is 9. So now which process is waiting? P1 is waiting with the burst time 1. So 9 plus 1 is 10. So next which process is waiting? P2 with the burst time is 2. 10 plus 2 is 12. So already P3 completed, so no need of taking. So this is our Gantt chart of round robin. So let us see the completion time of P1. So P1 completed, its completion time is 10. Next P2 12. Next P3 6. Next P4 9. So what is the turnaround time formula? CT minus AT, completion time minus arrival time. So 10 minus 0 is 10, 12 minus 1 is 11, 6 minus 2 is 4, 9 minus 4 is 5. So what is the waiting time formula? turnaround time minus burst time. So 10 minus 5 is 5, 11 minus 4 is 6, 7. 4 minus 2 is 2, 5 minus 1 is 4. So I need the average of waiting time. So average of waiting time is total waiting time by number of processes. What is total waiting time? See, calculate. 7 plus 5 is 12, 13, 14. 14 plus 4 is 18. So 18 by 5. 5 3s are 15. 3 is remaining, 0.36, 5 6 are 30. So 3.6% of average waiting time. So if you have any doubts, you can comment. In this session, we have discussed about round robin scheduling algorithm with preemptive method. So next session, we are going to see about classic problems on Peterson solution, semaphores, Peterson solutions, synchronization problems, and semaphores. Thank you.